Okay. So now we can get into the class. So in today's class, what will be dealing with this the topic that is studied. Okay. So the same topic also was dealt by me in your second year. The same exact topic only we are going to see in today's lecture. Okay. So in last, because small brief about last class. Okay. So last class we have seen about yeah. In last class we have seen about switching over voltage and protective devices have been used for switching over voltage. We have seen. So that has been origin how the voltage is happening, and the characteristics we have seen, okay, characteristics followed by after the characteristics we have seen the causes, okay, what are the causes for the switching
சார்
over
இந்த
voltage?
சார் எக்ஸ்கியூஸ் மீ சார்
Yeah.
சார் வாய்ஸ் வந்து கொஞ்சம் இறையிற மாதிரி இருக்கு சார்.
Okay, just a minute. Uh, just a minute. Be back. Yeah. Now you'll be getting the clear audio. Okay. So
ஓகே சார்.
yeah. Okay. So yeah, I have left in the previous class. Okay, so that how the high voltage lines get energized due to the switching over voltage we have seen, followed by the power frequencies in the over voltage due to the switching we have seen, and then the control, how you can control the over voltage due to switching we have seen, and after that we went to the protection part of your transmission line, how the transmission line can be protected from your over voltage in terms of both lightning over voltage as well as your switching over voltage we have seen. Okay, so you can use the ground points wire, expulsion gaps. Okay, so some devices like the protector tube mounting, so the and surge arresters or lightning arresters we have seen. So these are some devices which are used for protection. Okay, so from this point you can surely expect the protective devices you can expect. Okay, so now we will be moving on to your lecture 5. So your lecture 5 is entirely based upon your topic which you have seen, that is nothing but corona. Okay, so corona in terms of your electrical quantity will be seen. Okay, so you already know what the corona in terms of your electrical quantity. Okay, we have already studied in your T&D second unit. Okay, so this comes in your T&D second unit. The same exact thing only here we will be studying. Here actually I will be reviewing. Okay, so for you I will be just be giving some revision. Like okay, so some of the topics, and you can for further calculation you can go and take your T&D book and see. Okay, so in your T&D book it might have given very elaborately. Okay, here I have given out some brief points. Okay, so you can get into the topic directly. Okay, so corona. So what do you mean by corona in terms of your electrical quantity? So can anybody say? Okay, so you just see it. So here what they are saying is corona is nothing but a discharge. Okay, it is an electrical discharge. So it can be either a positive or a negative. Okay, how it is created means it is created by ionization of a gas. Okay, so we have already seen how the charges get separated in your clouds. Okay, similar to that, after separation of your charges in your clouds, what generally happens is ionization of gas around the cloud will be happening. The same concept only is also happening over here. Around the transmission line or the conductor, around the transmission conductor, what happens is the ionization due to the dampness or what you can say due to the water
வாய்ஸ்
droplet.
பிரேக் ஆகுது.
Okay, so for others it is clear, right? So now it will be somewhat clear. Yeah. So the ionization of gases only causes this corona. Okay. So how it happens means the same concept of charge separation near clouds. The same concept only is also here. It happens. Okay. So in general, what happens is due to this effect, there will be some kind of blue color sightings around the conductor. I'll be showing that blue color sightings in the picture. Okay. So this definition also you can write for corona. So the other definition is what they are saying is corona is a self-sustained electric discharge. Okay. So self-sustained means போதுமானது. Okay. So it is a electric discharge which is self-sustained in which the field intensified ionization is localized only over a portion of distance. So here what they are saying is within this corona won't be happening in your entire length of conductor. Okay, it will be in particular spot. Okay, it will be localized to a particular spot. Okay, so why in the sense means the dampness or the water droplets over there will be very high. So due to that droplets or the dampness in air, in general what happens is the ions will be ionizing they are able to ionize throughout the conductor. Okay. So what happens is on high voltage conductors and high pressures, visual corona under positive and negative conductors differs. So here, as I said, you might be seeing some kind of blue color nature, so blue color sightings over the conductor. So this differs in terms of your positive as well as negative conductors. Okay. So for positive conductor, if the corona occurs means it appears as a uniform bluish white sheet. Okay. It will be in terms of your blue color. Okay. In terms for your positive conductor. The same thing for your negative conductor means the corona will be in terms of your reddish glowing spot. Okay. Okay. So for this, I will be showing the picture. Before that, we can see the effects alone. So this effects alone you have studied in your T&D subject as a separate 8 mark. The same thing you just brief it out. So here I have given some points alone. Okay. What are the 5 points means the first thing what due to corona what you will be getting is some noise. Okay. Some noise you will be getting. So after that violet glow appears. Okay. So the same blue and red color they are saying. So the third point is here they are saying is ozone gas gets produced. So by liberation of one electron from your O2, okay, an oxygen ion will be forming. Okay, that oxygen ion will be gets bombarded with another one molecule of oxygen to form ozone gas. Okay, so through that concept, ozone gas will be formed. So ozone gases in general will be harmful. Okay, so the fourth is radio interference. So it causes some problem in your telecommunication device. Okay. So there's some loss of power in your transmission line also. Okay. So these are the effects, the main effects of your corona. So now I'll be showing you the pictures. So this is a picture which is blue. Okay. So that means this is taking place in a positive conductor. Okay. Here you can see it clearly. It is around the conductor. Okay, around the conductor, so there is some kind of bluish sightings. Okay, so some kind of bluish color is around the conductor. Okay, so this is one thing, and followed by the other. This is also another one kind. So it is also happening in blue color. Okay, so it also corresponds to your positive conductor. Okay, so in this there are some important what you can say 2 mark definitions. The same thing what you have seen in T&D will be repeating over here. So here what they are saying is corona inception voltage. Okay, so what is corona inception voltage means? It is the lowest voltage at which continuous corona of specified pulse amplitude occurs. Okay, so that is it is the minimum voltage, okay, around the conductor, okay, through which some continuous corona of specified pulse amplitude occurs. That is, here you can see, clearly you can see. So there is some pulse-like structures around the conductor. Okay, so these pulse-like structures will be depending upon your what you can say your voltage. That is the corona inception voltage. Okay, so here what I am saying is this voltage decreases as the frequency of your applied voltage increases. Okay, if you are giving the frequency more in the sense means like 49.5 other than the or 50.3 like that more than your power frequency you are giving out means your this voltage will be decreased. Okay, so where this occurs, this corona can occur in application as low as 300 volt. Okay, so next is the corona inception voltage in parallel wire. Here they have given the formula. So the same formula it is given in your T&D book. You just refer with that. Okay, so I won't be covering that each and everything. So here they have given the formula for your voltage gradient. So EC is nothing but your voltage gradient. So M is the irregularity factor. So it is depends upon your wire surface. So if your wire is a polished wire in the sense means this M value you can take it as 1. If it is a rough wire means you can take it as 0.93 to 0.98. So similar to that here there is variations. So next is the critical disruptive voltage. This you have already studied in your T&D, the same thing. So that is, what is this critical disruptive voltage means? There will be 2 conductors. Okay, if you are taking even a single phase means it will be having 2 conductors. One is your phase and another one will be a neutral. Okay, so the minimum phase to neutral voltage at which the corona occurs. Okay, so the minimum phase to neutral, which is nothing but your phase voltage. Okay, at which this corona occurs is known as critical disruptive voltage. So here what I am saying is, if the corona effect is occurring over this phase line means, that is in this L line if it is happening means, so the minimum voltage across this line with respect to your neutral, okay, line with respect to your neutral while the corona is happening, so it is called as critical disruptive voltage. So in general, they have given some standard for this critical disruptive voltage. So that is, here with respect to your breakdown strength of here what they are giving is it is 30 kilovolt, okay, 30 kV max per centimeter. It is the maximum voltage. If you are taking in terms of your maximum voltage, it is 30 kV, that is kilovolt max per centimeter, and with respect to your VRMS, that is root mean square of the voltage, it is 21.1 kV per centimeter. Okay, this is also a standard value. Okay, So next is the formula. So this formula you have to write if they are asking in terms of your 2 marks. What is the critical disruptive voltage they are asking means for the coaxial cylindrical cable, you have to write this one. So E is equal to 31 MD into 1 plus 0.308 root of D into R. So here where V is the atmospheric pressure, okay, A is the relative air density, and then T is the temperature in, small t is the temperature in pressure, sorry, degrees Celsius. And sometimes they might be asking problem. Okay, so it's like TND they only asking too much of problem in this section. So sometimes there's possibility. Okay, so they'll be giving the entire each and every parameter values. Okay, and you have to solve those kind of things. Okay, so for this you just refer with your TND book. Okay. So the next thing will be dealing with the advantages. Okay, advantages will be dealing. So the main 3 advantages they have given. Okay. So in general, due to corona formation, what will be happening? Okay. So the air surrounding the conductor becomes conducting. Okay. So in general, the air is the insulator. Okay. So it doesn't allow anything to conduct. But during the concept of corona, what happens is the air around this conductor gets ionized and it becomes conducting. Okay. Hence, virtual diameter of the conductor is increased. So, if here you can see. So, here around the conductor, the conduction part is increased. Okay. That's what they're saying. So this diameter of the conductor gets increased. Okay. The increased diameter, what happens? What it does mean? It reduces the electrostatic stress. Okay. So if the conducting area increases, means the stress between the conductors decreases. Why in the sense means the flow of current will be very easy without any kind of interruption. Okay, the current flow will be able to flow in more surface area. Okay, if the diameter increases. Okay, next is corona reduces the effect of transients produced by surges. Okay, so transients by surges you already know, right? The transients ma'am might have been taking, so I don't need to explain so much. So due to the surges, there will be a sudden spike in your voltage for a very short duration of time. Okay, that's called transients, and after some time period, it gets settled down. Okay, it gets settled down. The same thing only. So due to this corona effect, what in general happen is the effect of transient is minimized. Okay. So the next point is the transient produced by lightning surge and other causes also reduces the same point. Charge induced on the line by surges will be partially dissipated as corona loss. Okay. So in this, here what they are saying is if there is any kind of maintenance over the transmission line means, so before doing any maintenance or repair work in the transmission line, what the linemen have to check it out means they have to check it out that if there is any kind of static charges over the transmission line. Okay. So if there is any kind of static charge means it will be life-threatening phenomena. Okay. So the static charge will have a heavy damage over the body. So what happens is this static charges will be able to be partially dissipated as corona loss. If there is corona means. So it will be acting similar to a safety valve. So these three are the advantages of corona. Okay. When compared to your advantage, you'll be having more amount of disadvantage only. So this will be corresponds to your undesirable phenomena. Okay. We'll be moving on to disadvantages of corona. Generally, what happens? What disadvantage you'll be having is, so yeah, you can see this lightning is blue light is visible to you, right? So this thing, what happens is, it's a form of energy. Okay, this light which is visible to you is a form of energy. Okay, so through this entire conductor, there's some dissipation of energy. Okay, but for us, what is desirable is the conductor has to be flowing through, that is your electrical quantity must be flowing through the conductors, but here it is dissipating as losses. Okay, so that's the first point is the disadvantage. So corona is accompanied by loss of energy, so which directly affects your efficiency of the line. For example, if 11 kV line transmission line is there, then the 11 kV line, if from A to B, it has to travel means, and in between the point M, there is some corona loss means. In general, what happens is, so you'll be getting around nearly, instead of 11 kV, you'll be getting around nearly 10.3 kV, like that you'll be getting out. Okay. So here the main reason is the corona loss. Okay. The second point is, ozone is produced by corona. Okay. So due to this, what happens is, corrosion of the conductors may occur. There might be corrosion in your conductors also possible due to chemical action. Okay. This point and the fourth point is the same. Okay. And next thing is, harmonics are produced in the line. Due to the corona effect, the harmonics also will be induced. So excessive filters have to be embedded into your transmission line. Okay. So these are the major drawbacks of your corona. Next is the applications. So where and all they are using this corona as an application. So first thing is, they will be using for high-speed printing devices. Okay. High-speed printing devices like your laser printers, they will be using this effect. Next is the electrostatic precipitators. So in industries, this electrostatic precipitators you can see through. So the final is the paint sprayers. Okay. So we have seen about the corona. Next, we have to see how this corona can be prevented. It's very important thing, how it can be prevented. So the first thing is, corona can be avoided by minimizing the voltage stress. Okay. The voltage stress can be minimized. Okay. At the electric field. Okay. This is accompanied by using good high voltage design. Okay. So as I said, the ionization of your air occurs around the conductor. Okay. So it has to be this ionization occurs due to the voltage stress and the electric field gradient. So the first point to prevent corona is, you have to minimize these two quantities. Okay. So how you can do this? You can maximize the distance between the conductors. Okay, that have large voltage differential. Okay, you can maximize the distance. Okay. Then the second thing is, corona insertion voltage can sometimes be increased by using surface treatment area. Okay. So it is some kind of special treatment which they'll be using by your electric board. So this topic, the possible questions, what we can expect is, what is corona and explain its effects they might be asking. So this is a part B question they might be asking. So next, the effects of corona they might be asking. So this one you have already studied clearly as a 13 mark in your T&D subject. So next might be asking about explain the advantage and disadvantage of corona. Okay. So this is also they might be asking in terms of 6 mark or 5 mark. So finally they will be asking, surely they will be, can expect this question critical, disruptive, voltage. For your 2 marks you can expect. So here I have just given like a revision. Okay. So you just refer your T&D book for this. So this lecture 5 is getting over. So it's a small topic only. Okay? It's a small topic and can just